Before we get into binomial expansion, we're going to look at Pascal's triangle and how it can help us to multiply out brackets. So Pascal's triangle works like this. You start with 1. Now, there's nothing over here. So nothing add 1 is 1, and there's nothing over here. 1 add nothing is 1. And you keep going. Nothing add 1 is 1. 1 add 1 is 2. And 1 add nothing is 1. And you can keep going like this. Nothing and 1 is 1. 1 and 2 is 3. 2 and 1 is 3. 1 and nothing is 1. Here we've got 1. 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. And this would be 1. Now, you might ask, why on earth is this useful? Like, why would you bother? And the reason is, if you're going to multiply out brackets with a high power. So, for example, we'll just start with x plus y. Well, that would be x plus y power 1 would be 1x plus 1y. Now let's look on the next line and we can use the example of x plus y squared. Well, x plus y squared is x plus y times by x plus y. Now I'm always going to start on the highest power of x and work down. So we'll start on x squared, which would come from here. So we'd have 1x squared. And then we're going to go to x power 1, y power 1. So you would get that from there. 1xy plus, those two terms could be added together, and plus y squared. So this would end up being 1x squared plus 2xy plus x squared. Let's have a look at the next one. We're going to see if the coefficients mirror the Pascal's triangle. So we've got 1, 3, 3, 1. And we would be on x plus y power 3. So to do x plus y power 3, I would take x plus y and multiply it by x plus y squared. The reason why I wouldn't do x plus y times by x plus y times by x plus y is because in the previous step, I've already worked out the answer here for x plus y squared. So I'm going to substitute it in. So we've got all these coefficients from this line. Now here, I'm going to start on the highest power of x. So here I went from x squared, x power 1 to x power 0. And the reverse direction for y. Y power 0, y power 1, y power 2. So my x power was always starting on 2 and decreasing, whereas my y power was starting on 0 and increasing. So in this situation, to get the x cubed coefficient, I would do these two together. So that's x cubed. Okay, now I need to think about which ones would give me x squared. Well, x times 2xy, so I would be 2x squared y, and this one also, so there would be 2 together. So now I'd be adding 2 and 1, which is how we got the 3. Similarly, to do the next one, so those two would go together to be 3x squared y. Now, if I was doing the x power 1, I could get it in two ways. I could do this one multiplied by this one, or I could do the y times by this one. I'm going to put them in green so you can see them really clearly. X times by y squared, or I could do y times by 2xy. So in this case, I would be adding 1 to 2, just like we were here, 1 to 2 to get this 3 here. And the final term, the y cubed term, would come from timesing this one by this one. So this would end up being 1x cubed plus 3x squared y1 plus 3 xy2 plus y cubed. I wonder, without multiplying out, if you could work out what x plus y power 4 would be. Well, we would start here on the x4, and this would be decreasing each step. Now here we could think about that as x power 0, but remember x power 0 is just 1. And for y, we would do the opposite. We would start on 0 and increase. And if we added all those terms together, that would be the answer. So Pascal's triangle is a quick way to work out the coefficients when we're multiplying out brackets. It's really useful if you've got a high power and you don't want to be multiplying out using a FOIL method or drawing these lots and lots and lots of times. You can go very quickly, directly to the answer. Okay, that was a little bit of background information on Pascal's triangle, what it is and why it's useful to us here in A-level maths. And we're going to fast forward now to key skill 1. So I'll see you in the next key skill.